Hello, we are Baja Blast, and this is our final project video for MAE 152. For this project, we are working with the Baja SAE race car. Each person was in charge of 2 simulations. This is our first iteration of our chassis, which is somewhat simplified, but then as we moved along, we improved it and added suspension and more gussets, as you can see right here. The first simulation is a rollover impact on the chassis where there is 500 pounds applied to the top of the chassis. We did the same simulation on the second iteration of our chassis and it improved. We also applied the same forces on the side of both iterations. Here's the first iteration and here is the second iteration with the same forces applied to it. Here is a torsional rigidity simulation that we did where we applied 2 forces going in opposite directions where the suspension would be going. That is for our first iteration. And here's the free body diagram for our second iteration, which performed much better since the moment arm was larger and we had to apply less force. The next simulation is the side impact. The rear is fixed and a load of 500-pound force is applied on the side member of the chassis. The first model held up well with a stress below the yield strength. The second model experiences more stress but does not yield. We then performed the buckling analysis on the floor. The floor was fixed at the rear joints and has a load of 500-pound force applied at the front joints. The redesigned iteration adds an internal member and increases the tube diameter. We also did a few more simulations. This one is for the front suspension A-arm where we added a force where the shock would be, and we did this for the first and second iteration. Besides that, we also did a prescribed displacement on the roll bar for the first and second iteration. We do this in case the race car actually flips so we see the integrity of the roll bar during competition. We also did a heat flux simulation as well as a vibration study from applying thermal load received from the heat flux mesh. Besides this, we also did a bottom impact where we analyzed the chassis from adding forces to the bottom of both iterations. The second iteration is better than the first. The following is a front impact. The chassis is fixed at the rear lower joints near the firewall and has a load just under 10,000 newtons at the front member. This is to replicate a frontal crash at 25 miles per hour. As for our results, most of our static simulations were done so we could understand how the chassis would respond to certain forces in different areas. Some key results to be noticed were from the torsional rigidity simulation and the side impact simulation.